Hello, this is Mrs. Ringrose, and we are back at it again, trying to learn everything we can about systems before the end of the school year. Today's goal is to introduce you to the substitution method, and if you can be really good at solving systems using the substitution method just by doing a couple of the steps, then that's really the goal for this lesson, so that would be awesome. Alright, so first of all, let's remind ourselves what a system of equations are, and it's basically two or more equations. So that means there's two rules that we have to set up, and we have to find the answer to both so that we have an answer for our real life problem. So again, in this course, we're just going to look at two linear equations. But it can be, it doesn't have to be linear. And you might explore that in Algebra 2 or other math courses. So today we're learning the substitution method. And basically, this word substitution is going to tell you what it is that you're doing. It's just basically, you substitute over and over until you get an answer. And I am going to list out all the steps, but if you can just get the general idea that substitute means plugging in and solving, and then plugging in and solving, you'll be good to go. So you may be asking yourself the question, why do we need another method? Graphing seemed to work so well for me. I don't want to learn anything new. Why do I have to know how to answer something two different ways? Well, here's the problem. Alright, so in one of the questions I gave you, you might have been thinking this. So what happens if I have one line that looks like this, and the other line looks like this? Alright, does that look like a whole number? No, I mean it looks pretty close to 1.5, but only in the x. I wouldn't say that's 1.5 in the y. So, we need to have another method because if our answer is not whole numbers or something that we can easily estimate, also, what if our answer is in like the hundreds or thousands? I don't want to sit there with a graph and trying to scale and graph up to numbers that high. So basically, why do we need another method? Not all equations can be graphed easily. And we just need to have an algebraic method. So also, graphing only works well for whole number answers. Technically, instead of whole, I should have used the word integer, which means the negative and positive whole numbers. So graphing works well for integer number answers, but not for numbers that are not integers. So here we go. Here's the steps. So step 1 means make sure that one of your equations is in y equals or x equals form. So if you look below under example 1, you'll notice that one of those equations say y equals. So that means that that step is done for you. The example number 2, I don't have that. So that would be an example of when you need to go ahead and put one of those equations into x equals or y equals form first. Step 2 says that what we're going to do is substitute that expression, which you might not know what that means yet, but we're going to substitute that into the other equation to solve for one of the variables. Alright, so that's step 2 is already, we're substituting and we're solving, and I'm going to show you how to do that. Okay, and then step 3 is you're going to substitute the answer you just found in step 2 back into an equation and solve for the other variable. You usually want to use the equation that's y equals or x equals to make your math a little simpler, and again I'll show you how to do that. And then your final step should always be your favorite step. No, it's not your favorite step, but check your solution algebraically. And that's just what I had you practicing on the first day, which is why we spent so much time on the graphing method. So below I have some examples for you. And if you feel like you got this after 2 examples, then you can shut me down. But I have some examples on the next page that I can run through with you as well. So I'm going to erase this circle. So, and I hope you have the steps written down so you can look back at them, because I really feel like that's helpful. Step 1, make sure that you have an equation that's y equals or x equals, and I have that. So what I like to do is I like to box off that part to remind myself that y is equal to whatever x is plus 1. Then step 2 is I'm going to substitute that expression, or I'm going to take everything that's in that box and plug it in where y is. So all this is equal to y, right? So it's all going to get stuck in for y up there. And I'm a big fan of the arrows because I don't want to substitute in the wrong spot. So now what I'm going to do is I'm going to rewrite this equation 2x plus, and instead of y, I'm replacing y with x plus 1. So up until now we've been substituting in numbers and values for variables. So this is an example of where we're substituting in a whole expression. And then I finished up the equation there. Now this is a really good place to stop and make sure you only have one letter left. If I had x's and y's left, then that means I put the stuff in the box in the wrong spot. Now my next job is to solve. So we've had lots of opportunities to practice our solving skills. This is 2 plus 1x, which is 3x, plus 1 equals negative 2. Now what I need to do is get that negative 1 put over to the other side. So I'm going to minus 1 from both sides. Right, so I'm subtracting 1 from both sides. That cancels, and I get 3x equals negative 3. And then my final step is to divide both sides by 3. And I get x is equal to negative 1. But what's so much fun about solving for systems is that we're not done. The fun is never done. So this is my answer for x. Remember, if I graph these, then there would be 2 numbers because I need an x coordinate and a y coordinate. So then what I'm going to do is I'm going to take this negative 1 and go on to step 3, which is substituting it in for an equation so I can find y. Now it really doesn't matter which one you put it in, but that y equals equation is going to make the math easier. So y equals x plus 1, and I'm plugging in negative 1 there. And then that means that negative 1 plus 1 gives me 0, so that means my y is 0. So my answers are negative 1 comma 0. Again, this is a location on the graph, so it should be put into an ordered pair format. Okay, so this is my answer that I'm looking for. Then the last step is to check your work. Now I'm not going to use the second equation because that's kind of how I got my 0, but if I can check at least my second equation, that would be great. So my second equation was 2x plus y equals negative 2. So let's try that out. Is 2 times negative 1 plus 0 equal negative 2? So I plugged in my negative 1 for x and my 0 for y. 2 times negative 1 is negative 2. And that's true. So I've done all the steps right there for example number 1. Okay, the next one, you'll notice that I do not have anything that says y or x equals. And we're going to do something a little bit differently because you might be looking at this and thinking, oh, I always have to get y by itself. Well, that's not the case always. If I look at the first equation right here, if I try to solve for x, I'm going to end up with 3 divided by 2. And that's going to be ugly. And the same thing would happen with the y. And then the second equation, if I try to get y by itself, I'm going to be dividing things by 4, and I'm going to have a lot of fractions. So that's not the best way to do things. You'll still get the right answer if you do, but the best thing to do is to choose this equation and solve for x because it has a coefficient of 1. Alright, so I'm going to take this equation, I'm going to add 4y to both sides because the positive and negative cancel out, and then my equation is x equals 4y minus 1. All right. So then I have to move on to step number 2, which is to box off this expression, and it's equal to x. I'm going to plug it in for x right there. So I'm going to rewrite this. 2 times everything in the box. All right, use those parentheses, plus 2y equals 3. Before I get into any hard work, I'm going to take a step back and make sure that I don't have both x's and y's. I just have y's. So I must have done something right. Then what I need to do is distribute the 2. We didn't have to distribute on the other one because y had a coefficient of 1 on the other equation as well. But unfortunately, that's not always going to be that easy. Remember that 2 gets multiplied on both of those numbers. All right, I have like terms, right? I have 8y and positive 2y, so I have 10y. Minus 2 equals 3. Gotta get the y by itself. To do that, I'm going to add 2 to both sides. So now the negative 2 and the positive 2 cross out, and I have 10y equals 5. And then I have to divide both sides by 10. All right, and the answer is actually 0.5, and that's a thing, right? So y equals 0.5, and it's good that we did a different method than graphing, because if I saw 0.5 on the graph, it might be hard to estimate. All right, but I'm not done. This is just what my y is. Now I have to take, because the fun is never done, I have to take this 0.5 and plug it in to an equation. This one I have 3 equations, and it really doesn't matter which one. But I'm going to use that one. So 4 times 1/2 is 2, and 2 minus 1 is 1. So my answer, my x comes first, is 1, 0.5. Seems like an awful lot of work, but I'm not done because we're never done with the fun on these. So the last thing I want to do is just check into my first equation. Let's see. So I'm going to use this equation that says 2x plus 2y equals 3. Does 2 times 1 plus 2 times 0.5 equal 3? And the answer should be yes, because 2 times 1 is 2. 2 times 1/2 is 1. And 2 plus 1 is 3. All right, so again, if this isn't, I'm not going to have enough time to go over a lot of examples, but I'm obviously your resource in class. So if you feel like this is enough for you to get started on your own, do it. But if you still need a little bit more guidance, I have 2 minutes left on this video. I'll get you started on this one. Take that x minus 4, plug it in for y because it's all equal to y. So then I have 4x plus x minus 4 equals 26. Combine like terms. Add 4 to both sides. Divide both sides by 5. And I have my x already. So then I'm going to take this number, which is 6, and plug it in up here. So y is whatever x is minus 4. So that means y equals 2. And my final answer is 6, 2. I'll let you check my work algebraically, but it should look like, does 4 times 6 plus 2 equal 26? And the answer should be yes. All right, I really like doing this next one that's to the right, because a lot of students think that the easy ones are confusing. So if you look at the second equation, it just says 5y equals 15. Bam, pick that one. I don't know why I did 3. Divide both sides by 5. Get that y by itself, and you find that y is 3. So bam, I already got my y. Take this 3, stick it in there. So then I have 3x's minus 3 equals 0. I can add 3 to both sides. And then a divide. And x equals 1. And again, I'll let you go for it and check the math for me. And I hope this helps introduce the substitution method. You have a great day.